Alright, so now we're going to do for physics on the topic electricity, where we discuss internal resistance. We will look at a 23 mark question. Why can't I get charge up pen? So I don't think I've charged my pen. That would be a schlep. That would be a nuisance. Yeah, I don't think I've charged my pen. Okay, let's see if this pen is that fine. Alright, so we're doing again electricity. Also, let me rather say potential difference EMF internal resistance. Internal resistance. And this is on electricity. Okay, so we're doing it's a typical exam question when you're in matric. So it's 23 marks. Oh, you share a screen. Let me share screen. Yeah, what's showing now? It's showing my screen. Oh, that water tasted delicious. And put the charger on the tablet. All right. So we have a circuit in an exam type question. Our circuit looks like this. We have a battery made up of cells. And we've got ammeter there, ammeter 1. We've got resistor of unknown resistance. So we'll just say it's got X ohms. We've got a voltmeter connected in parallel to the battery, and it reads 20 volts. Voltmeter always connected in parallel. Then we have a resistor here. Let's call it R2. That will be 1. And it's got 16 ohms. Yeah. We've got a switch that's closed. Switch, not the energy drink, switch for a circuit. Yeah, and then we've got A2, which connects in series again. And then this resistor R2 is in parallel. It's parallel to R3, which let's say it's 4 ohms. And another resistor, which is also 4 ohms, and we'll call that R4. And a voltmeter, the second one, is connected there, and it reads 4 volts. All right, so this question is for 23 marks. It's not max, it's marks. And we must calculate several things. So each of these, when we calculate them, they give us marks each time, every step. Né? The first thing we must work out for number 1A is reading on ammeter 2 or A2 when the switch is closed. Né? So yeah, when the switch is closed. So how do we do that? Ammeter A1 is in series to the rest of the circuit. So, or rather A2, sorry, my bad, A2. When we look at our circuit, ne, ammeter A2 is closest to this resistor, but that's not the reason. So, but it reads, okay, since the direction of conventional current would be that way, yeah. So this would read the current from this resistor here, right? It will read the current. So ammeter A2 reads the current that flows through a resistor of 4 ohms, which is this one here, R3. Ne? And that current would be the resistor of the 4 ohm resistor would equal the voltage of the 4 ohm resistor over the current of the 4 ohm resistor. And I guess it's an easy pass because that's like the only ammeter where we've got both a reading for voltage and resistance, and we won't struggle so much. So that is 4 ohms and voltage is 4 volts. Therefore, the current is 1 ampere. For the reading on A1, it gets a bit tricky, ne? The reading of the resistance, or rather the rating of this resistance here, it's 16 ohms, and it's twice these two that are in series. Okay? It's twice the resistance of these two that are in series. And from Ohm's law, when we have an increase in resistance, it is because we have a decrease in current. And when we have an increase in current, we'll have a decrease in resistance. So, the 16 ohm resistor is double the resistance of the 4 plus 4 ohm resistors, which is 8 ohms. Meaning that the current that flows through the 16 ohm resistor is half the current that flows through these two. So if 1 ohm flows this side, then half an ohm should flow that side. So current for 16 ohms equals half the current for the 4 ohm resistor. And this would be 0.5 amperes. Therefore, the reading of the current here would be that half plus the 1, which is 1.5. So I total would be 1 plus 0.5 amps, which is 1.5 amps. And that's the reading at A1. A1, not the supermarket, A1, the ammeter in this circuit. Okay. And then for 1C, we must find the resistance of resistor R. The resistance of resistor R. And how do we get there? How do we get there? How do we get there? Let's get Okay. So how we would think about this is that 1 over the resistance of the parallel circuit. The parallel circuit would be this one here. This is the parallel circuit. So if we want to make it an equivalent resistance, we'll need to add this resistor plus that as follows. So over here, let's just make it in yellow. Then take that over there. So we will have, not yellow, I want it black. 1 over R parallel, and that equals one over R1. No, not okay. In this case, I'm using R1, so it's not the case. We will have 1 over the 16 plus 1 over these two we can regard as one resistor. So that will be 8 ohms. So 1 over 8 ohms. And we regard these as one resistor for the simple fact that they are in series. And because they're in series, then the resistance should be the sum of their resistance along this line of the circuit. So we would have over 16, 1 plus 2, and this gives us 3 ohm over 16 ohms squared, and that equals 1 over the parallel circuit. And that means the parallel component has got 16 over 3 ohms, which is 5.33 ohms. And the external resistance of the circuit should equal the total external voltage divided by the external current. And the external current, we just calculated it now, is that 1.5. Ne? Whereas the external voltage is the 20 volts. So 20, we're going to divide it by 1.5, and then we get 13.3 ohms. Now, having gotten that, then the resistance for the unknown resistor should be the difference between the two, which is the difference between the two. So R1 would be external resistance minus parallel resistance, which is 13.3 minus 5.3 ohms. And that equals, what's 13 minus 5? It should be 8. 13.3 minus 5.3. And it should be 8 ohms. Okay? Then after finding that resistance for resistor R that we don't know, so now we know that it's 8 ohms. It's 8 ohms. Okay. We need to now find the internal resistance, so that's C. So for D, we need to find the internal resistance of the battery. And the EMF should equal the total voltage, and the total voltage should be the external voltage plus the internal voltage. And the total voltage, which we calculated somewhere, no, we have not calculated that yet. Oh, yes. It's 24 volts given. I forgot to write that. So that will be 24 volts equals 20 volts plus V internal. Therefore, the internal voltage should be 4 volts. And now from that information, we can calculate the internal resistance. And how do we do that? Remember our formula for internal resistance that we use is it's what's that formula we derived recently? Yes, there we go. The EMF also equals I into the total resistance plus the internal resistance. And we know that the electromotive force is 4. The current is 1.5 amps. The total resistance would be, I hope I'm not making a mistake here. Hey, it looks like I might be making a mistake, but let's just see. If it's incorrect, we'll correct it. We'll correct it. Let's do this instead. We know the total voltage is 24. That's given. That equals I times R total. Whereas this equals the external voltage which would be 20 volts, so it would be I. No, I'm making something wrong here. I need to think about this. If we have that V, it should equal the current times the R. Yes, because this electromotive force is the voltage inside the battery, so it must be tied to the current that's flowing and the internal resistance. And since we know the current is 1.5, then that means that the 4 volts equals 1.5 amps times R. Therefore, R would be 4 divided by 1.5, which is 2.66666 ohms. Okay, and let's just check the total or rather, that will be 2.6 plus 8 plus. I just want to see something. This plus 13.3 plus 5.3 plus 8 will be 29. Okay. This one, I'm not sure what exactly I'm doing. Not sure exactly what I'm doing, but I'm just trying out stuff. Okay, but quick recap. For this type of problem, we will get 2 marks here. 1 for the correct answer and 1 for correctly identifying that in this case, we are looking at the 4 ohm resistor, which in this case is R3. And in this part, we will get 5 marks for identifying that the resistance in this, the current in this resistor is half that in the 2 resistors, these 2. So that would give us the 1 mark there and the other mark there. Now when we calculate, we should also include in our calculation that these 2 give us 8 ohms. So we should include somewhere there that these 2 are 8 ohms, and we'll get a mark for that because R3 plus R4 equals 8 ohms. So that gives us a mark. That's the 3rd mark. And then calculating the 0.5 gives us a 4th mark, and getting the 1.5 gives us the 5 marks. So you wouldn't get a mark if you didn't declare this like I hadn't declared it before. And then in the next part, you get 4 marks for correctly working out the resistance of the parallel configuration. We get a mark for the correct answer and a mark for the calculation of the resistance in the parallel circuit. And then we also get a mark for finding the external resistance as well as correctly identifying the formula, and the final mark for the actual resistance of R1. And then here we would get a mark for correctly identifying that we need to use this formula, substituting, and then calculating the internal resistance. Now going forward, we will calculate the energy. Let me just switch slides here for you. We then calculate the energy transformed or transferred in 10 minutes in the resistor of 8 ohms. So in 8 ohm resistor or R1, work done in 10 minutes would be 10 minutes equals 100 and, or rather 60 seconds times 10 minutes, and that gives us, that doesn't look right. Let me say 10 minutes times 60 seconds per minute, and that gives us 600 seconds. And the work done, will quote the work equation, the work formula, which is I squared times the resistance times the change in time. The current we know is 1.5. We square that. The resistance is 8 in the resistor, and the change in time is 600. And that gives us, when we calculate, 600 times 8 times 1.5 times 1.5. That gives us 10.8 kilojoules, or 10,800 joules. And we will get 3 marks, 1 for the formula, 1 for correctly substituting, and for the correct answer. Now we have to discuss what would happen when the switch is open. What do you think will happen? We have to explain, so if we were to discuss that, when the current flows, V1 reads the external potential difference. Right? So part 2. So when the current flows, V1 reads the external potential difference. So this is in the case of a closed circuit. So V1 reads external potential difference. Now the second thing we must note is that when S is open, then there is no current flow, or rather the situation changes. And when it changes in our circuit, we end up having fewer resistors that are in parallel. Okay, so in other words, the 16 ohm resistor changes the situation at the parallel resistors. And then we find fewer parallel resistors. Then what happens is the external resistance increases, the total current decreases, the internal voltage decreases, the EMF does not change. And the external voltage increases. And then here we'll get a mark for identifying that there's fewer resistors in parallel. There's an increase in external resistance, a decrease in total current, decrease in internal voltage, no change in EMF, and a change in the external voltage. And all of those would be 23 marks. Now, another type of exam question that will pop up would be multiple choice. Yeah, ask.
50 MB.
Oh, okay. Yeah, we can stop here, but at least we discussed an exam type question. Yeah, it's in the learning guide, Mind the Gap.
Okay.
Mind the Gap learning guide. It is on page 111, and it takes the whole page. So this is page 111. Eh?
111.
Yeah, so let me just switch the slide so you can see it. So it's unit 7. So you'll find it there. Are there any questions regarding Google Classroom?
No.
So I've added you to the grade. I've added all my learners from grade 10 to 12 in one group, which is grade 12. So you'll find all the material, including these notes that I keep updating and the videos that I also keep updating on the grade 12. So I've added you, I think, on the grade 11 and the grade 12. Just go to the grade 12 one, you'll find everything there. You'll have to scroll a bit, but if you go to the classroom tab, let me share the screen.